All right, this is going to be the last addition subtraction proof I do that's this simple, because at this point they're very, very repetitive. But for our last proof that's going to look like this for our even and odds is we're going to ask ourselves, is the difference between an even and odd number always going to be odd? Well, let's look at just some examples, right? We can ask ourselves, let's say 2 is our even number, minus 3 for our odd number. Well, that's simply going to be -1. -1 is in fact odd. Or we can do something like, maybe not. Well, actually, yeah, let's do 2 minus 1. That's going to be 1. 1 is an odd number. We can do a large number if we really wanted to, like 10 minus 5 is going to be equal to 5. So that is in fact also an odd number. So it's looking like the statement is true. More precisely, more mathematically precise, what is our actual statement that what is the question we're asking here? Well, we're trying to prove because we're asking for any even and odd, it's going to be for all proofs. So for all A, B that are integers, if A is even and B is odd, then let's write that bigger, A minus B is odd, right? For all integers A and B, if A is even and B is odd, then A minus B is odd. Is this statement true? We think so, right? We've seen some examples. I can't really think of any that the difference would be even. So let's try proving this, right? So first, it's a for all proof. How do we start a for all proof? We let, right? So let's write down let. And what do we let? We let A and B be integers. What do we do then? We suppose our P. So we say where A is even and B is odd, then what can we do? Well, let's more concretely, more mathematically define what it means for A to be even and for B to be odd. We can say then A is equal to 2k and B is going to equal to 2c plus 1. I'm trying to always use different letters so you don't get used to a certain notation. 2c plus 1. And now that we've defined what A and B are, but we've now introduced k and c, so we should probably define what we mean by k and c. So we say where k comma c are integers. Fantastic. Next, there's nothing else for us to really define here, so now we've got to get on with our actual proof. We're going to try this and see if it leads to something that can show us it's going to be an odd integer, right? So we say then, comma, A minus B, you can then plug in our definitions of A and B, 2k minus 2c plus 1. What can we do here? Well, we're looking to show that this can look odd. Odd is going to be something in the form of 2m plus 1, where m is going to be an integer, right? So we're going to try and look to get 2k minus 2c plus 1 to look like that. Well, we can maybe factor out a 2 here. So we can say 2 multiplied by k minus c, leave the 1 alone, and there we go. You just have to now acknowledge that the difference between any integer is still going to be an integer. So you can then say where k minus c is an integer, so A minus B, or let me write that down over here, A minus B equals 2 times k minus c plus 1. So, making A minus B odd by definition. Okay, great. And just a quick conclusion. So we've now proven the difference between an even and an odd number, or the sum of a negative odd number and an even number is always going to be odd.